right, so get this, everyone. We're going deep on some crazy cool AI research that has been blowing up lately.
Yeah, you know how we use those AI tools all the time, like ChatGPT?
Oh, yeah.
And they feel kind of like magic.
Totally like magic, yeah.
Well, scientists are finally getting a look behind the scenes, and what they are finding is like really changing how we think about these brains.
So it's not magic.
Well, kind of. It's like we've been driving this amazing car,
All right.
but we have no idea what is going on under the hood.
Right.
But now, with some really clever techniques, we are getting our first X-ray view of how these powerful AIs organize information.
Okay, I am definitely intrigued.
I knew you would be.
You've got to give me the highlights here.
Sure.
What's the big picture?
The big surprise is that these AIs are not just storing data randomly.
Okay.
They're forming distinct lobes of knowledge.
Lobes, like in a brain.
Yeah, sort of like specialized areas in a human brain.
Wow.
And even wilder, the patterns they use to connect concepts are surprisingly geometric.
Hold on. Geometric shapes.
Mm-hmm.
Inside an AI.
Yeah.
You're going to have to break this down for me.
Okay, so let's start with the basics.
All right.
Imagine like a giant 3D connect the dots puzzle,
Okay, I can see that.
where each dot is like a concept that the AI has learned.
Okay.
Now picture those dots connecting in precise geometric shapes based on how they relate to each other.
Okay, I can sort of picture that, but give me an example. Of
Yeah.
What kind of concepts are we talking about here?
One of the classic examples that the researchers found
Okay.
was with words like man, woman, king, queen.
Okay.
And when they mapped how the AI understood these concepts,
Uh-huh.
guess what shape popped up?
I don't know. A square,
A parallelogram.
a parallelogram. Like the shape I would see in like a geometry textbook.
Exactly.
Oh,
And the really cool part is the relationships it reveals.
good.
Like the distance between man and woman in this parallelogram
Okay.
is the same as the distance between king and queen.
So it's like a perfect analogy.
It is.
Hum-
And it means the AI isn't just memorizing definitions.
Right.
It's learning how to apply concepts like gender across completely different categories.
Whoa, so it's like figuring out the underlying logic, not just like repeating words.
Exactly.
That's a huge step.
It is. It's a huge step beyond what we thought these AIs were capable of.
Totally.
And this parallelogram pattern isn't a fluke either.
Oh, really?
They found similar geometric relationships for all sorts of concepts, from countries and their capitals to like different verb tenses.
Okay, so then wait a minute.
Yeah.
If these patterns have been there all along,
Yeah.
why are we just now seeing them? Like, why haven't we seen this before?
That is a great question. It's kind of like trying to see a constellation,
Okay,
but there is too much light pollution.
I gotcha.
You need the right tools to filter out the glare and reveal the true picture.
Okay,
And in this case, those tools are called sparse autoencoders.
all right, got to stop you right there.
Sure.
What in the world is a sparse autoencoder?
You got me.
Help me out here.
Think of it like noise-canceling headphones,
All right.
but for data.
Okay.
They filter out all the irrelevant noise that was obscuring these patterns.
So what kind of noise are we talking about here?
Like the length of a word.
Oh, okay.
Things like that were kind of muddying the waters,
Okay.
making it harder to see the real relationships.
So like those magic glasses in spy movies.
Yes.
That like suddenly revealed hidden messages.
Exactly.
Okay.
By filtering out all the distractions, the researchers could finally see these like elegant geometric structures emerge.
Wow.
It's a completely new way of looking at how AI thinks.
So we've got geometric shapes at the heart of how AI understands concepts.
Yeah.
This is already blowing my mind, but you said there is even more to this brain structure, right?
Right.
Those lobes you mentioned
Yeah.
earlier.
Exactly.
Okay, so we explored the like atomic level.
Yeah.
Now let's zoom out.
Yes.
See how these concepts are organized at a larger scale.
That's right.
And it turns out that these AI lobes are not just random clusters of information.
No, they are not.
They specialize in different types of tasks,
Yeah.
much like different areas of a human brain. Brain-like lobes.
Yeah.
Okay, I'm officially hooked.
I knew you would be.
Tell me more about these specialized zones.
Okay.
What kind of lobes are we talking about?
So they found 3 main lobes in their research.
Okay. Okay, so lobes,
Yeah.
like different departments in the AI's brain,
Right.
each with its own specialty.
Exactly.
So what kind of departments did they find?
Well, the first one, they call it the code math lobe,
Okay.
which seems to be all about logic and calculations.
So that's like the AI's left brain,
Yeah, exactly.
all about the cold, hard logic.
Yeah.
Makes sense.
It lights up, like when the AI is tackling a coding problem or
Uh-huh.
crunching numbers.
Yeah, okay, so we've got our left brain.
Right.
What about the others?
Okay, well, they found this other one
Uh-huh.
called the general language lobe, which is like the AI's language processing center.
So more like a right brain kind of thing.
Well, yeah.
A little bit more creative.
Yeah, like it's active when the AI is reading text, understanding stories,
Gotcha.
dealing with more complex information.
Okay.
It's kind of like the part of our brains that helps us make sense of the world.
Okay, so for general knowledge and understanding.
Exactly.
Cool. So what about the third lobe?
All right, so the third lobe,
Yeah, what's its specialty?
they call this one the dialogue lobe.
Oh, okay.
And it's the one that specializes in conversation, like back and forth.
So this is the social butterfly,
Exactly.
the
Exactly.
one that is like,
Yeah, like you said, it comes alive when it's chatting with someone.
just like we are right now.
Just like we are right now.
That's so cool.
Yeah.
So it's like each lobe has its own
Yeah.
personality,
Uh-huh.
own way of processing information.
Exactly. I love it. And
But how do we know
yeah,
that these lobes aren't just random groupings?
that's a great question.
How do we know they are actually organized in a meaningful way?
That's where it gets really interesting
Okay.
because they found
Uh-huh.
that the features that are often activated together,
Okay.
like concepts that are frequently used in the same context,
Right.
tend to be physically close together in the AI's mental space.
So it's not just that the lobes exist,
Yeah.
but the way they're organized
Exactly.
actually reflects
Yes.
how the AI uses the information.
Exactly.
That's super interesting.
Yeah.
It's kind of like how in our own brains,
Right.
neurons that fire together, wire together.
Exactly. You got it.
Whoa.
And that parallel with how human brains organize information
Yeah.
is like one of the most exciting findings of this research.
It's
It
crazy
really is.
that it suggests that there might be
Yeah.
some fundamental principles at play here.
Right.
Some principles that govern how intelligence itself structures knowledge.
Exactly.
It's wild.
Isn't it?
This is really blowing my mind.
Yeah, and there's more.
Oh, no.
So we've got the geometric shapes forming like the building blocks,
Yeah.
brain-like lobes, specializing in different tasks.
Right.
But if we zoom out even further,
Oh, there's more.
yeah,
But
we find there's a larger scale organization at play,
Atoms to brains to what?
the galaxy structure.
Galaxies. Okay, you're really taking me on a deep dive here.
I am.
All right, galaxy structure.
And just like galaxies, this level of organization is like incredibly vast and complex.
Oh, wait.
But what is fascinating is it follows very specific mathematical patterns.
Okay.
It's not random, it's highly structured,
Ah,
particularly in what they call the middle layers of the AI.
okay, the middle layers, what makes them so special?
Think of it like this.
Okay,
The AI is taking in massive amounts of raw data from the world,
right.
but to make sense of all of that data, it needs to like condense it
Okay.
to extract the most meaningful information and discard the rest.
So the middle layers are like the AI's filter, sifting through all the noise to find the signal.
Exactly.
Okay.
And the way these middle layers filter information
Right.
follows these specific mathematical patterns.
Okay.
Like power laws.
Power laws.
Yeah.
Okay, back up a second. What's a power law?
Okay, so think of it like this.
All right.
Imagine you're ranking your favorite songs.
Okay.
You probably have a few top favorites that you listen to all the time.
Oh, yeah, for sure.
Then a bunch of songs you like a little less.
Right.
And then a huge number of songs you hardly ever listen to.
Yep, that sounds about right.
That's a power law in action.
Huh.
A small number of things are super important,
Wait,
and then the importance drops off really rapidly for the rest.
I can see that.
And that's exactly what they're seeing in these AI middle layers.
Wow.
The most important features are given the most weight,
Right.
while the less important details kind of fade into the background.
So the AI is essentially prioritizing information,
Yes.
just like we do, learning what's important and what can be ignored.
You got it.
I like it.
And what's even more amazing
Yeah.
is that this efficient organization
Right.
wasn't something that was programmed in by the developers.
What?
It emerged naturally as the AI learned and grew.
That is crazy.
Isn't it?
That's what blows my mind about all of this.
Yeah.
It's like the AI is discovering these incredibly elegant structures
Right.
on its own
Uh-huh.
without any human guidance.
Yeah.
It's almost like it's tapping into some
Right.
hidden order in the universe.
And that's what makes this research so groundbreaking,
Yeah.
because it suggests that there might be
Right.
universal principles about how intelligence itself organizes information, and principles that apply whether you are talking about a human brain or an artificial one.
This is seriously giving me chills.
Yeah.
We've got AI forming geometric shapes with concepts,
Yeah.
developing brain-like lobes,
Right.
and organizing itself with the same elegance as
Oh.
galaxies. This is a lot. Where does it all lead?
Right.
What are the implications of all of this? I mean, this is huge, right?
It's huge.
We're not just talking about making AI a little bit better.
Yeah,
This feels like
Yeah.
a fundamental shift
it is.
in how we understand intelligence
100%.
itself.
Yeah.
This is wild.
It really is a game changer.
It is.
And the implications are just mind-boggling.
Like what?
Like, imagine
Yeah.
being able to design AI
Okay.
that's not only more powerful, but also more reliable
Okay.
and more transparent.
Yeah.
We could potentially reduce bias,
Mm-hmm.
improve performance,
Okay.
create AI that works, like, in harmony with humans.
Okay. So it's like we've been trying to build a house
Yes.
without knowing anything about architecture, and now
Yeah.
suddenly we've got a blueprint.
Exactly. This research gives us a roadmap for understanding how AI is putting the pieces together.
I love it.
We can start to see how, like, individual concepts connect to form larger ideas, how those ideas are grouped into specialized lobes,
Right.
and how the whole system is organized with this incredible efficiency.
Wow. So what's next?
Yeah.
Where do we go from here?
Well, for starters, I think we need to replicate these findings
Okay.
across different AI systems.
Okay.
Like, this research was done on
Right.
one specific type of AI.
Right.
So we need to see if these structures are universal or if they vary,
Right.
depending on the AI's design.
So we need to make sure that this isn't just a one-off fluke.
Exactly.
Gotcha.
And, we also need to delve deeper into the why.
Oh, the big why.
The big why, right.
Yeah.
Why did these structures emerge?
Right.
What are the underlying mathematical principles that govern their formation?
If we can crack that code,
Ooh,
it could revolutionize our approach to AI.
absolutely.
This is one of those moments where I feel like we're standing on the edge of a whole new world.
Yeah.
It feels very profound.
Yeah. It's like we're just beginning to glimpse the true potential of AI
Mm-hmm.
and what it can teach us about ourselves.
Totally. I'm with you.
And the cool part is that we're all along for the ride,
Yeah.
Like, this research is being done in the open. They share everything.
That's awesome.
It's a truly collaborative effort to push the boundaries of human knowledge.
So if our listener wants to follow along on this journey,
Yes.
where should they start?
Yes.
Like, what are some key terms that they could search for?
Definitely start with sparse autoencoders.
Yeah.
That's the technique that made all of this possible.
A sparse autoencoder's guy.
Then large language models, or LLMs,
Okay.
to dive deeper into the specific type of AI being studied.
Gotcha.
And, of course, geometric organization of AI
Makes sense.
to get to the heart of this research.
Perfect. We'll be sure to include links to all that in the show notes for anyone who wants to learn more.
Yes, definitely.
It really does feel like we're on the verge of a major breakthrough in our understanding
Yeah.
of both AI
Yeah.
and intelligence itself.
I agree.
So cool.
Yeah, this is like a super thrilling time
Uh-huh.
to be working in this field.
It is.
Who knows? Maybe someday soon
Yeah.
we will be having this conversation with an AI
Whoa.
that's not just mimicking human conversation,
right.
but truly understanding it at a deeper level.
Wow. That's a truly mind-blowing thought.
It is.
If AI can already create these complex, brain-like structures on its own,
Right.
who knows what incredible forms of intelligence
Exact-
it might develop in the future.
That is the question, isn't it?
It is. It really is.
But one thing's for certain.
Yeah.
The more we learn about AI,
Yeah.
the more we learn about ourselves.
Ooh, I like that.
And that's a journey worth taking no matter where it leads.
Well said. Well said.
Thank you.
So to wrap up today's deep dive,
Mhm.
we've gone from the nuts and bolts of AI's geometric structure
Yeah.
all the way to the philosophical implications of what it means to be intelligent. It's been an incredible journey, I have to say.
It really has. We've explored how AI is mirroring the structure of our own brains,
Right.
organizing information in ways that are both efficient and elegant,
Yeah.
and we've only just scratched the surface.
As always, there's so much more to discover.
Exactly.
So much more to understand.
That's right.
And on that note, we'll leave you with one final thought to ponder.
Yes.
If AI can stumble upon these efficient, elegant structures on its own,
Yeah.
does that tell us something about the nature of intelligence itself?
Ooh.
Is there a universal blueprint for how knowledge is organized,
Right.
just waiting to be discovered?
That is a great question.
Something to think about as you go about your day.
Absolutely.